Hello everyone. The subject information theory and coding. In here we will discuss in lecture 3, basically we discuss entropy. In lecture 1 we have discussed in basic block diagram of digital communication system how information theory and coding is related with digital communication system in first lecture. In second lecture we have discussed what is the information. Okay. In short we have discussed. Now in lecture 3 all about entropy. This is the syllabus which already I have shown in the last slides. In 1 minute we can revise whatever we have discussed in lecture 2. Then first, information in common sense. We have discussed that I is proportional to 1 upon p. P is the probability of occurrence of the event, and next we have seen that because p is when p is 1 then I is 0 and p is 0 then I is infinite, then I can be a logarithmic function of 1 upon p, and information I is nothing but the measure of surprise or measure of uncertainty associated with that event. We have discussed in the last lectures. Okay. Then information I is directly proportional to surprise associated with that event, and which is directly proportional to uncertainty associated with that event. Then we have discussed information in engineering sense. Here we have represented that basically information that is measure of the surprise. Then in engineering sense, in commercial sense, when we want to measure the information, basically when any event surprise us, then we want to express it with the maximum number of sentences, words, bits like that. Then in engineering sense we measure the information in bits. Whatever the number of bits, that bits directly number of the bits directly proportional to the surprise associated with that event. If the surprise is associated with that event, then information will be more and more. Then more number of bits will be required to express that about that event. Okay. Then more number of bits required to express that event which has some surprise. Then in engineering sense, I equals to log of base 2 1 upon p. P is the probability of occurrence of any symbol at the output of the source, and base 2 basically base 2 then it base 2 makes its unit as a bits. Okay. Then in engineering sense I is equal to log of 1 upon p base 2 in bits, and all the information will be in the binary form in 0 and 1. Okay. In 0 and 1 means like that if there is a text, then that text can be converted into the binary form. Any audio signal, that also can be converted into the binary form through sampling, quantizing and encoding, and similarly any video signal also, that also can be converted into the binary form. Then basic is the binary information associated with the any event, that is that expressing in terms of text, in terms of audio, in terms of video, pictures like that. Source statics are source probabilities. Any source with some as a output with some symbols at the output, then every symbol has some probability, not necessary to be equal. Then those probabilities of the different symbols from that source known as the source probabilities. Like that, if S is equal to S naught, S 1, S 2, like that S n minus 1, then every symbol has some probability like that P naught, P 1, P 2 and P n minus 1. Okay. And average information and entropy, then every symbol there is a source, it is the source, and at the output at one time one symbol can come at the output. Okay. Then what is the probability, that probability of occurrence of that symbol at the output of the source, that is probability P naught for the symbol S naught at the output of the source, probability P 1 for the symbol S 1 at the output of the source, and so on. Okay. Then we can calculate information associated with every symbol in terms of I, I naught, I 1, I 2, I n minus 1, that is the I. Okay. And this information associated with every symbol, we can find its average, I average. Okay. When these symbols are equiprobable, then we can find average by summing the information and divided by n. But because these symbols are not equiprobable, every symbol has some probability, then I average will be equivalent to I naught P naught plus I 1 P 1 plus I 2 P 2 and so on, I n minus 1 into P n minus 1. This is the I average. Okay. And we can express in terms of equation I average, that is the I k P k, k equals to 0 to n minus 1. Okay. Now, next source of information. Okay. Here we are assuming that our source is discrete memoryless source. What is the discrete memoryless source? Discrete means discrete source that its output in terms of symbols, one symbol at a time at the output. Okay. There are some finite number of symbols associated with that source. Okay. And memoryless means that these symbols are statistically independent with each other. With that independency, they are coming at the output of the source. Okay. This is the discrete memoryless source. Okay. Here we are getting symbols S naught, S 1, S n minus 1, any symbol in random way at the output, and every symbol having some probability to come at the output. Okay. Then discrete memoryless source, source alphabet. There are some properties associated with the source we can discuss, like that source alphabet. Okay. Then every source, this source have some alphabets. Okay. These are finite in number. Then source alphabet, this is important thing associated to be with the source. Next, symbol rate. At the output, how many symbols are coming at the output in 1 second, that is the symbol rate. Number of symbols per second coming at the output, that should be known. Source alphabet probabilities, then every symbols have some probability, okay, and with that probabilities those symbols are coming at the output. Probabilistic dependence of the symbols in a sequence. Here we have discussed that the symbols may be statistically independent, but in next the symbols may be dependent with each other also, maybe depends on the past symbol coming at the output, that also we will discuss in the next lectures. Information vessel probability as a logarithmic function plot, if we plot I versus P, suppose this is the probability of occurrence of the event, I is the information, that is the log of 1 upon P base 2, then at P is equal to 0, P is equal to 0, information is infinite, and at P is equal to 1, information is 0. Okay. Then if probability in between, then we can see we can find I corresponding to that. Now, properties of information. See some properties. First properties, that is when P is 0, I tends to infinite. When P lies between 1, I always positive, 0 to infinite. Okay. And second, this one. Third property, that if Px is less than Py, suppose, then information associated with those events, those have this probability Px and Py, then information Ix will be greater than Iy. Okay. And fourth, if symbols are statistically independent, okay, then with the probabilities statistically independent symbol, independent symbols, then I x plus y equals to I x plus I y. Okay. If they are statistically independent, okay, and if they are dependent with each other, okay, then I x plus y equals to I x plus I y minus I x y, that is the mutual information on that associated with those symbols. Okay. This is the properties of information. Average calculation of information, that we have done already. Now, entropy of the source. See, entropy of the source here in information theory and coding, basically the average information associated with the source, that is the entropy of the source, we represent it as H. Entropy of source, that is the average information, associated with each symbol of the source, then it can be given as k is equal to 0 to n minus 1 pk ik. Okay. Then basically entropy, that is the average of information, and the information associated with each symbol, that is the minimum number of bits required to represent the symbol, so that without distortion those symbols can be decoded at the destination. Okay. Then basically here is the average minimum information, that is known as the entropy. Here you can say that is the average surprise associated with the source, average uncertainty associated with each symbol of the source. Okay. This is the entropy of the source. Properties of entropy. See, when probability Pk is 1, then entropy Hk can be 0, and its maximum value Hk is log of k base 2 log of k base 2 when Pk is 1 upon n, it should be Hk is log of n base 2, log of n base 2. N is the number of symbols associated with that source, and Pk is 1 upon n. If Pk is 1 upon n means if all symbols are equiprobable, every symbol has equal probability, only when Hk can be maximum. Okay. We can prove this, that Hk lies between 0 to log of n base 2. Okay. See, we know that one inequality that ln x a log of x base e, this is less than equal to x minus 1. We can plot it, this inequality log of x less than x minus 1, suppose this is x, this is y, then y is equal to x minus 1 will be x minus 1 will be from here ln x like that, this one. Okay. And ln x less than x minus 1, then it will be passing from here to here. This is the ln x, log of x, this is the x minus 1. The log of x is always less than equal to x minus 1 and meeting at the point x is equal to 1. This is the x is equal to 1 point. Okay. These are meeting points. Okay. We will use this inequality to prove this, that Hk has maximum value log of n base 2. Okay. We can take Hk, just a minute. Suppose summation small k is equal to 0 to n minus 1 Pk log of base 2 Qk upon Pk. It is a one quantity. Okay. Suppose this is we have to find this in log of base e. When convert it into log of base e, this can be written as 1 upon log of 2 base e summation small k is equal to 0 to n minus 1 Pk, okay, log base e Qk upon Pk. Okay. This is log 2 base e. Okay, okay, it is correct. Now, this thing log of x less than x minus 1 less than equal to, this inequality can be imposed here, then this will be less than equal to 1 upon log 2 base e summation k is equal to 0 to n minus 1 Pk. This is less than equal to x minus 1, that is the Qk upon Pk minus 1. Okay. It can be expressed as 1 upon log 2 base e summation k is equal to 0 to n minus 1. If you multiply it inside, then this comes Qk minus Pk. Okay. And this is less than equal to this one. Here Qk and Pk, what is Qk and Pk? that is the source S with symbols S naught S up to Sn minus 1, Pk, there is a probability distribution associated with that source Pn minus 1, and Qk is another probability distribution associated with the same source. Okay. Here we can assume that this Qk is equiprobable, then every symbol with the equiprobability and every symbol with different probability. Okay. These probability distributions may be given. Okay. Then we know that summation of Qk 0 to n minus 1, that is 1, summation of Pk 0 to n minus 1, that is 1, then 1 minus 1, then it will be 0, then less than equal to 0. Then we can conclude that this quantity is always negative. Okay. Just a minute. Okay. That quantity was summation k is equal to 0 to n minus 1 Pk log of base 2 Qk upon Pk, that is less than equal to 0. This we have proved in the last slide. Okay. Now, here as we have assumed that Qk is equiprobable, that is Qk is equal to 1 upon k. If we put this value Qk is equal to 1 upon k, we can get that k is equal to 0 to n minus 1 Pk log base 2 1 upon Pk is less than equal to log n base 2. This is nothing but the Hk, that is the entropy of the source. Okay. The entropy of the source Hk is value log of n base 2 when equiprobable. Okay. This is the case. Okay. Then we can say Hk is always less than equal to this one, and it is positive already because information is positive, its average is positive, then Hk can be lies between 0 to log n base 2. Then this is the properties of entropy finished. In next class we can discuss entropy of binary memoryless source, entropy of extended source with examples. Okay. These are some references which you can see. Thank you so much.